Hey everybody, this is Mr. Schultz here with you. We are going to take a look at 731. How can I use an equation? So using equations to make predictions. This will be kind of going back to our scatter plot stuff and just trying to use these equations to be predictive. So previously you've learned to find and extend patterns in data and to make predictions using rules, equations, and graphs. Today you will apply these mathematical tools to a real situation in which your data does not make a perfect pattern. Okay, so we're going to be starting off with question 7-88, and this is about Arhali's bike ride. This is a French word here, and I did look up how to pronounce it. So hopefully Miss Micklin will approve of my pronunciation here if you're in French. So to prepare for a 30-mile bike ride for charity, Arhali has been biking every weekend. To predict how long the charity event will take her to complete, Arhali has been keeping track of her time and distances. She tries to ride at a constant pace, but of course that is not easy to do. Now, if you're looking at the paper book, this first one is question A here. If you're using the ebook, then it should look just like this screen. Would a box plot, a scatter plot, or a histogram be most useful in helping Arhali make a prediction? So thinking about this, which of these things would be best? Well, a histogram, that's kind of based off of bins and putting this data into like specific bins, but none of these things are really close to each other. You know, you've got 80, 150, 104, nothing really close to that kind of bin approach. Doesn't really seem to be a good idea. A box plot, well, that's just saying taking averages of the different things and finding the different medians and whatnot. Might work, but with just kind of this thing about not going at a constant pace, that kind of leans towards a scatter plot because you're going to be trying to make some sort of a generalization there. So let's use a scatter plot to help make that prediction. So this is actually part B in the paper copy book or part A in the ebook. Basically, I'm going to change this question sum and just say try to make a prediction. How long will it take? Will take Arhali to complete the 30-mile charity ride? So why don't you pause the video here and just take a look at this data that you've got right here. How long is it going to take her to do a 30-mile ride? How much time is it going to take for her to do a 30-mile bike ride? All right, so now that you're back here, so I'm looking at this, I'm saying, okay, well, here's one that's 25 miles. It took 150 minutes. So I think it's going to be more than that. I need about 5 more miles. Let's see here that it took about 35 minutes to do 3.5 miles. So let's just call that, I don't know, let's call that another 50 minutes. So if it takes 50 minutes roughly to go 5 miles, let's just add that on to our 25. So 50 plus 150, I'm going to guess around approximately 200 minutes it's going to take her to go 30 miles. So my prediction is going to be 200 minutes. Yours might be a little bit different than mine. It might be lower, it might be higher. I just say that you want to be kind of roughly in that ballpark. From anywhere from I'd say about 170 to about maybe 230 or so seems to be kind of a decent range to have your prediction be in. Let's take a look at the next slide. Okay, so let's finish up the rest of this question, which says, which is the independent variable and which is the dependent? So again, here's our chart here. We've got the minutes and the distance. Anytime that you see time, some sort of a measure of time, minutes, second, hours, days, weeks, months, that is considered your x. So we're going to put the minutes down in the x-axis. We're going to put the distance up in miles in the y-axis. So independent is going to be x, and the dependent is going to be y. Now it says make a scatter plot. So I basically just want to take these points right here and I want to plot them into this graph here. We could definitely use some practice with this. So let's see what this looks like. So if I go over to 68 minutes, then up to 7 miles. So I'm going to go on my x-axis. I'm going to move over to 68. Here's 60. Here's 80. So 70 is probably in the middle. So 68 is probably right about there. And then I need to go up to 7 miles. Well, here's 5 miles, 6, 7 miles. So I'm just going to go and plot this point here. So 68 and 7 miles. I'm going to guess it's somewhere right about there. Then I'm going to do the next one again too, just so that you see more of this. And then I'll finish out the rest in just a second here. So 88 and 17. So I'll go out to 88 and then I'll go up all the way to 17. So probably something like that. Finish up the last four points here, and then we'll bring it back in. All right, so here are the rest of the points that we have on our scatter plot. Yours should look basically the exact same here. Shouldn't really be a lot of variation. It should be very, very close. I'll zoom in here so you can kind of see this a little bit more clearly. But your points should all be very, very close, if not the exact same of what you see here. Let's take a look at the next question. So the next question says, use a line of best fit to predict how long it'll take Ahali to complete the charity ride. Remember that the line does not need to intersect the points and that the line does not need to pass through the origin to model the data. So it doesn't need to pass through 0. It doesn't need to pass through all of the points. I'm just trying to draw a straight line here. We're going to use Pear Deck to try this. So there will be a link that should be popping up in the description. So take a look at that link. But here's what that'll look like. Okay, so if you take the link from the description, it should take you to a screen like this. It might ask you to sign in with Google or something like that, but I'm assuming that you're probably signed in, so you can feel free to answer the question or skip it, but I'm going to answer the question here, and then it's going to load up the Pear Deck here. And so Pear Deck looks like this. It's got our screen just like we saw on the previous slide, and you've got your pencil tool, your highlighter, your line tool. Well, we're trying to use the line of best fit. And watch this. When I do this, oh, hey, that's really big. That's too big. I can't really see what's going on. So I'm going to undo it. Right here is this sizer tool that you can make your dots really big, or you can make them very small. So we're going to make a line of best fit. So since I'm going to do a line, I'm going to go back to my line tool. And again, I'll use that sizer to size it down. And I'm going to just choose a color just to make it a little bit easier to see. See, I've got a little bit of residue left here, so I'm going to try to take that off as well. And I'm just going to try to rough out my line of best fit. And remember that you do not need to intersect each of the points, and the line does not need to pass through the origin, which is at 0, 0. So I'm going to try to just create a line that kind of cuts this data in half, gets about 50% of it above, 50% of it below. So what? Let's do something like, something like this-ish. And that's going to be our line of best fit there. So now that you've got your line of best fit, let's see if we can use that to make a prediction, just like it says in the question here. So it says, use the line of best fit to make a prediction as to when she will complete the 30-mile charity ride. So let's zoom in and see, okay, at 30 miles, which will be this line, go over here. Well, I've got my point kind of roughly right there. I can't really see exactly where it's at because it's not going through on a kind of nice, easy x-axis point. It's going somewhere between these two. So it's somewhere between about 175 and about 180. So it's somewhere between there. Maybe we call it, 178. Something like that. Take us about 178 minutes approximately. But let's see what we do with this now if we don't know it exactly. But it's a pretty close ballpark. But let's see what happens next in our next problem here. So our next problem, 7-89, says this. Using an equation to make predictions. Sometimes it is more convenient and more accurate to use an equation to make a prediction rather than just trying to interpret the graph. So we're going to choose 2 points that lie on the line of best fit, which I made mine a little bit thinner here so that we could kind of just see it better. And then we're going to use those lattice points. Remember, lattice points are the natural points that things cross. So a point where both y, x, and the line all cross. And we're going to use those points to calculate slope. So let's see what this looks like. Let's choose a couple of lattice points here. So I'm just going to zoom in and choose some real natural lattice points here, which is just kind of where it's crossing. So it looks like I have got a nice lattice point. Closer up top here, let's call it right about here. So it's crossing on x and y. So this point is going to be at 60, and it looks like that's at about 7. Oh, not 70, but 7. So 60 minutes and 7 miles. Let's choose another one. Let's try this one right here. Looks like this point is going to be at about 40 miles and about 3 minutes. So I've got my nice lattice points. So now I just need to make my growth triangle to figure out what the slope is. So I'm going to go up 1, 2, 3, 4 miles. for every 5, 10, 15, 20 minutes. So remember, the slope is going to be my rise over my run. So I'm rising 4 miles for every 20 minutes. So if I were to simplify that, that'd be 1 mile every 5 minutes. 1 mile every 5 minutes. 1 mile every 5 minutes. So the slope is equal to 1/5 once it's nice and reduced down. So what does the slope mean in terms of her biking? Well, we just talked about that. That means 1 mile every 5 minutes. That's just what the X and the Y are. That's just what the miles biked here. And then I can't see it on this, so let me zoom into it here. Every minute here, which there are 20 minutes for every 1 mile there. So next one, what is the Y-intercept on your line of best fit? If you didn't draw that all the way to the Y-axis, which is this line here, it's a great chance to go back and do that. But I'm just looking for, where does it cross? Looks like it's crossing it at about -5. So this is kind of a weird thing, but it's saying this, that at -5 miles, so basically your Y-intercept is going to be this. It's going to be at 0 because it's 0 on the X-axis. It's going to be at -5 in the Y-axis. What does the Y-intercept mean in terms of Arhali's training? Well, it kind of makes a weird situation here, which is saying that at 0 minutes that she's gone -5 miles, which kind of doesn't make a ton of sense. Lots of times when you're making a prediction, sometimes some of your points won't make a ton of sense, and that's okay. It just means that there might be some things like, hey, when she starts her bike ride, when she's got those first few miles, that let's say that it's really hilly, so it ends up taking her longer at the beginning, which is what's making that look more negative there. So just your Y-intercept is going to be at 0 and -5. Let's take a look at the last two parts here. Okay, so part C says write the equation of the line of best fit in y equals mx plus b form. Identify your variables. So for writing an equation, y equals mx plus b, where m is just my slope. So I'm just going to plug in my 1/5 that I found from before. And b is my y-intercept, which is at -5. You could write this as plus a -5, but I am just lazy and don't want to have to write the plus a negative when I can just write the minus sign. My x and my y are going to stay the same because y is going to be the number of miles biked. X is going to be the number of minutes. Those are the things that are changing. So x is equal to minutes, y is equal to miles. And that's our last part there of identify your variables. Now part D says use your equation to predict how long the charity ride would take Arhali to complete. So here, if I know it's a 30-mile ride, well, that's in y, that's my miles. So I'm now going to do a little bit of solving. I'm going to say that 30, or let me just write my equation here quick again so that we can kind of see this. I'm going to erase this. So y equals 1/5 x minus 5. So now 30 is the length of the trail, so that's 30 miles will be equal to 1/5 times by x. That's what I'm looking for. How long? That's in minutes. Now I just need to solve this. So remember, I'm trying to get x by itself. So I'm just going to add 5 to both sides to make a 0 pair here. Got 35 is equal to 1/5 x. Now 1/5 x, remember I'm doing the inverse operation. So if I've got 1/5 of x, well, I need a whole x. So to make this a whole, I need to multiply by 5. Whoops, I've got to cross out my 0 pair there. So I'm going to multiply by 5 on both sides. So 1/5 times by 5, well, that's just 1. So I'm left with just x. These two things will cancel. And then on the other side, I've got 5 times by 35. So I come out here 5 times by 35, ends up being about 175. So right in that range of what we had talked about with that first line of best fit where I said about 170 to about 175, we came up with the exact number of 175 minutes. And so the last thing is just how does it compare? Well, originally we said 200 minutes. So we were a little high, but not too bad. Not too bad. Just a little high there. So that's what our line of best fit does. It helps us be predictive, helps us be able to make some kind of generalized things. So basically, here's what you want to be able to get out of this day in summary here. So in summary, 1, you want to be able to draw a line of best fit on Pear Deck. And, well, drawing a line of best fit is your best first step. So line of best fit. And then you want to be able to use the line to make a prediction. To predict. And whether that's solving for your Y or solving for your X. So these are the 2 things that you're looking to be able to accomplish by the end of today. Is being able to draw that, and especially on Pear Deck, and then use that line to make a prediction on 30 miles is about 175 minutes. Okay, that's a whole bunch of everything. Have a good rest of your day.